All right, let's dive into a really cool story. It's about a hidden connection, a link between a fun little brain teaser posted online and a massive, high-stakes cybersecurity problem. We're talking two completely different worlds, but it turns out they were unlocked by the very same idea.
So it all kicks off with this puzzle, a question posted on Stack Overflow, which is, a huge Q&A site for programmers. Now this looks like a classic combinatorics problem. That's just the fancy math of counting and arranging things. Basically, how many unique piles can you make with a bunch of colored balls? Sounds simple enough, right? Well, it's way trickier than it looks.
So the user, who calls himself the Darbear, says his professor gave him this problem and he was just stuck. He couldn't figure out where to even begin. The community chimed in, of course, but the real solution, well, it came from a totally unexpected place.
And here's where the story takes a fascinating turn, because the best answer to this puzzle had absolutely nothing to do with balls or colors. The whole problem was actually a clever disguise for something else entirely.
It turns out, after the Darbear talked to his professor again, he learned where the puzzle actually came from. It was a variation of a problem from a competitive programming site called Caddis. And that one little clue changed everything. It revealed the secret. This wasn't about combinatorics at all. It was about number theory. The secret weapon was prime factorization. You know, where you take any number and break it down into its essential prime building blocks. In this new way of looking at it, each prime number is like a different color, and its exponent, how many times it shows up, is the number of balls of that color. The puzzle was never really about balls. It was about the fundamental nature of numbers themselves. So the solution is actually pretty elegant once you see it. Step 1, you just reframe the entire problem. Forget balls, think prime factors. And as soon as you do that, boom, it turns into a famous computer science challenge called the knapsack problem. I mean, think about it like you're packing a bag with a weight limit and you want to cram in the most valuable stuff possible. It's the same idea. And once it's a knapsack problem, you can just use standard, well-known algorithms to solve it. By just changing the way they looked at it, the impossible puzzle became totally doable.
Okay, so a super clever solution to a fun puzzle. Just hold on to that thought. We're going to switch gears now into a world with much, much higher stakes, cybersecurity. What happens when the very system designed to protect a huge company's sensitive data is just too slow to actually work?
Meet Next Generation Access Control, or NGAC for short. This thing is a beast. It's a powerful, standardized framework designed to stop data leaks by giving organizations incredibly fine-grained control over who can touch what. It's like a master system for managing all sorts of different security rules at the same time. But there was a huge problem. The official versions of this system were unbelievably slow. They were running on what's called cubic time algorithms. Now that means as you add more users or more files, the time it takes to check permissions doesn't just grow, it explodes. It got so bad that the system was basically useless for any real-world company.
So, under the hood, the NGAC system is built on something called a graph. You can think of it like a big, complex map of connections. On one side, you've got all your users and what they're allowed to do. On the other side, you've got all the data and files. The technical name for this is a directed acyclic graph, or DAG, which is just a fancy way of saying it's a network where things only flow in one direction, no loops.
So how in the world did they fix this? Well, this brings us to the big breakthrough. See, the problem wasn't in NGAC itself. The idea was solid. The problem was the painfully slow algorithm trying to make sense of that graph. And the solution? Well, it changed everything.
Researchers at NIST, that's the National Institute of Standards and Technology, came up with a new algorithm they called P-review. And here it is, the amazing connection. Just like with the ball puzzle, they solved the problem by completely reframing it. Instead of a clunky rule-by-rule check, they started treating every access request as a simple path-finding problem. Can this user get to this file became, is there a valid path on the map from point A to point B?
And the results? I mean, just look at this chart. It tells the whole story. On a system with 10,000 nodes, one of the old implementations just gave up. It timed out after a minute. The original NIST version took a whopping 22 seconds to answer one question. But the new P-review algorithm, 0.08 seconds. We're talking less than a tenth of a second. It wasn't just an improvement, it was a total game changer.
So, let's put it all together. We have a programming puzzle that got solved by thinking about prime numbers, and we have a massive cybersecurity system that was fixed by thinking about finding paths on a map. What's the thread connecting these two completely different stories?
The connection is the principle itself. It's this powerful idea of abstraction. In both cases, the answer wasn't found by just trying harder with the same approach. The breakthrough came when they changed what the problem looked like. They went from counting colored balls to factoring prime numbers. And they went from checking endless security rules to simply finding a path on a graph.
So you might be thinking, okay, it's faster, big deal. But the crucial point here is that this is about so much more than just speed. This change in perspective has a profound, real-world impact on whether a system is even usable, and ultimately, whether it's even secure. So, before preview, imagine you're a security admin. This is what you had to stare at all day. To figure out who had access to what, you had to navigate this incredibly confusing tree of abstract policies. It was a total nightmare. You literally had to be an expert in the system's guts just to answer a simple question.
But with the new algorithm in place, you get this. A clean, simple, and intuitive file and folder view that looks familiar to absolutely everyone. All that crazy complexity we just saw, it's still there under the hood, but it's completely hidden from the user. It just works.
And that's really the heart of it all. Finding the right algorithm, the right abstraction, isn't just a nerdy trick to make things faster. It's what separates a powerful but impractical idea from a tool that people can actually use to keep things safe. It turns the unmanageable into the intuitive.
It really makes you wonder, doesn't it? How many other huge, impossible problems out there, in all sorts of fields, aren't impossible at all? They might just be waiting for someone to come along and look at them from a slightly different angle, a simple, elegant change in perspective that unlocks everything.